So I'm sure we remember back from middle school or high school in general or algebra that when we have a quadratic polynomial such as this, we can actually factor out into binomial factors to solve for the solution of x so that equals 0. So for in this case, we can actually factor out. So we have that x plus 3 multiplied by x plus 2. And then we have that our x values equal -3 and -2. And just if you want to verify yourself, you can actually use the FOIL method just like from high school. X times x is x squared, x plus times 2 is 2x, x times 3 is 3x, and then 3 times 2, 6. X squared plus 2x plus 3x plus 6. It comes down to x squared plus 5x plus 6. And it comes down to that x equals -3 and -2 so that the solution equals 0. And you can actually verify this yourself if you'd like to. So now let's actually take a look at another quadratic polynomial such as this, where it cannot be easily factored. So what does this mean? We can actually use, if you remember, the quadratic formula, where the formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And then you just plug in the constants as follow. A corresponds with this, b corresponds with here, and then c corresponds with the constant right here. So if we plug in those values, we have that it's x is equal to -8 plus or minus the square root of 8 squared minus 4 times 1 times 3, all divided by 2 times 1. And it comes down, so we have -8 plus minus square root of 64 minus 4 times 3 is 12, so that's 52. And I'm just gonna leave the square root as it is without having to like compute it with, because just for time's sake. All this divided by 2. So that's where x equals this, such that we have the solution that it equals 0. So keep in mind that quadratic formula can only be used on for quadratic polynomials, meaning quadratic polynomials have the highest degree of the second power. It will not work if you were given a polynomial as like a cubic polynomial or any degree higher, 3, 4, 5. It would not work. It only works with the second power only. If you're not able to find factors of x, like in the binomial factors in this form. Now with this, since this can be factored, it can still work that you can still plug in a equals 1, b equals 5, c equals 6 into the quadratic formula, and you'll get that the solution is the same as these two right here. It'll still work either way, but this is actually factorable in a way that there's no need to use the quadratic formula, such as this. We cannot factor it out easily in binomial factors, which is why we have to use the quadratic formula to solve for those solutions of x. Now, but that's not what this video is about. The bigger question you might want to ask, you might be curious or thinking to yourself is, how exactly did we get the quadratic formula of this form in particular? How did this exist in the first place? Or how can we find an x such that it satisfied the solution of an ax squared plus bx plus c equals 0, where a, b, and c can be any number, any real number in general. So today we're actually going to derive that, or in this case prove how the quadratic formula exists. So the way we're going to start this, let's start by saying again ax squared plus bx plus c equals 0. Again, a, b, and c, real numbers. Just keep that in mind. I'll actually write that notation just for the sake of it. C, B, real numbers. So now, the proof itself is generally it's pretty simple. It's all just straight algebra. And what we're gonna do first is we have ax squared plus bx. Subtract the c to the other side so that we have equals to -c, and then we can divide a to both sides of the equation. So now we have x squared plus b divided by a times x equals -c divided by a. So now the next step is to figure out what's the next step here? Well, you can't really factor out an x, because the whole point of this is we want x to be on one side of the equation, and we want the constants on the other side, a, b, and c, all those being constant on the other side. Because otherwise, if you were to factor out an x, you have x times x plus b over a, but then it won't do you justice, because if you want the constant to be on the other side, you would have to divide the x plus b over a, but leaving the x on the opposite side of the equation. And that's not what we want. We want the x variable to be on one side and the constants to be on the other side, such that we can find any solution for x such that it satisfies the formula ax squared plus bx plus c equals 0. So the method we're going to use here is we're actually going to be completing the square. So what is that going to do? So we're going to take this second term right here. It's like pretty much like filling in the gaps, and to the point where when we do this, we have b over a, so that divided by 2, so there's b divided by a, divided by 2a, and then add, and then square, and then you would have to do that to the other side, so it would come down so that we would have x squared plus ba x, then plus b divided by 2a squared. Don't forget, you have to add this term to the other side as well. A then plus b divided by 2a squared. And so we'll rewrite this out again. So we have x squared plus b divided by ax, and then that will be plus b squared divided by 4a squared. Same thing for the other side, negative c divided by a plus b squared divided by 4a squared. And if you actually take a look closely, this can actually be factored into binomial factors. So what we have is that we can actually have x plus b over a, or excuse me, b over 2a. Stop. 2a, and then multiply again plus b over 2a. And if you want to verify this, and if you want to verify, we just use the FOIL method, x times x squared, x times b over 2a, so it's b times x divided by 2a. Over here, same thing, b over 2a. You add those together, and then we get that it's 2bx divided by 2a. Those 2's will cancel out, and then you have b over a times x. And then for the last one, b times a over times b times a. Same thing, b squared 4a squared. So it actually turns out that this is actually a complete square. So we can actually rewrite this as x plus b over 2a squared. And now that we have this side to focus, let's actually get a common denominator. So we're gonna set this to 4a squared. This will be just b squared right here. And because we have and then we're trying to set a common denominator for this 4a squared, we have to multiply the 4a to negative c. So this will be negative 4ac. And this matches specifically the same as this term right here, this constant mainly. So now we can combine that, and we have it's b squared. It's they have the same denominator, and then this is under addition, so it's commutative. So I'm actually just going to move the b squared to the other side, so that we have a leading positive number. Square, or b squared minus 4ac, and then divided by 4a squared. And now we have this equals this. Simple as that. The rest is pretty straightforward in general. We just take the square root of both sides. So we take the square root of x plus b over 2a squared. Set this equal to the square root of b squared minus 4ac divided by 4a squared. And we have that the squares will cancel out, so we just have x plus b over 2a, and then this is equal to b squared, or the square root of b squared minus 4ac, and then you could actually take the square root of this, it comes out evenly, so it's 2 times a, 2a. And they have the same denominator, so we can write this as x equals, subtract the b, divided by 2a to both sides. So we have the square roots of b squared minus 4ac divided by 2a, subtract b over 2a, and then set this into the same denominator. So we have that x is equal to negative b plus or minus. Yeah, make sure you put a plus or minus here because this is the square root. This is the square root, so we have to consider both positive and negative values. So plus or minus the square root of b squared minus 4ac divided by 2a. And that's it. We have the quadratic formula right here. Like this. Very simple. And as said before, this formula can be used in any quadratic polynomial. You just make sure you set your constants into, make sure you set them correctly. B corresponds with the middle term, A corresponds with the first term, the leading coefficient, and then C is the constant, last term of the quadratic polynomial. And as said before, quadratic formula can only be used for quadratic polynomials or functions. You cannot use it in any sort of degree higher than 2, 3, 4, 5 cubics, any kind of those polynomials. It would not work if you're trying to use this. If you're using this formula to solve for any x value so that it satisfies the solution that it equals 0. So just make sure you keep that in mind whenever you're trying to look for solution, any x values. And yep, and that'll be it. So thank you guys for watching. Feel free to like, comment, and subscribe. I actually go check out the Gaussian integral that I did previously. It's actually an interesting one. And that's pretty much it. So see you guys. Done.